So this one is exercise 2 of space physics with answer key. The first question is complete the following sentences by choosing the word from the box. Each word may be used once, more than once, or not at all. You can use a screen annotation to complete this. This is related to star cycle. So the first one, that is giant. If a red giant star is a large enough, it may eventually blown up in an explosion, which we call supernova, and leaving behind a very dense neutron star or a black hole. Black hole is not an option here.
Sir, but it's
Yeah.
a must like red super giant, not giant. It's not
No,
written here.
even red giant classification, even red supergiant is because in reference to the question, they sometime even for a supergiant, blue supergiant, red supergiant, they can also say red giant. But they give you a hint. They will say that this is having a red giant is having a very high mass. So they give you an idea that this red giant is very heavy. So it's likely to undergo a cycle of star which is massive rather than a low mass star.
Yes, sir. Okay.
Yeah, red giant, blue supergiant, blue giant, red supergiant all have a same meaning. So question 2, explain how stars like sun were formed, and then the sun is made from mostly hydrogen and eventually the hydrogen will be used up and the sun will die. Describe what happened to the sun from the time the hydrogen is used up until the sun dies. So first thing, the formation of a sun. What happened in a formation of a sun initially? Basically
First, Mr.
Yeah.
Clouds combine together to form molecular clouds, and they will form a protostar.
Yeah.
Then after the protostar, when it's stable, like the radiation force and the gravitational force, when they are equal, they will form a stable star, which is in its main sequence.
Good. That's a good answer. Yeah, that's also right. Interstellar cloud join pressure balances and it will have a main sequence star. So the idea is that the first point, like what happened, it will form a giant cloud of gases and hydrogen is there. And then uh, as a result, what will happen? The gravity increases, so everything will be pulled and a hydrogen fusion will start. And when hydrogen fusion balances with like the radiation pressure balances with a gravitational force, gravitational pull, the sun will be like a main sequence star or a stable star. The second one, what will happen? The sun is made from mostly hydrogen. Eventually, the hydrogen will be used up and the sun will die. Describe what happened to the sun from the time hydrogen is used up until the sun dies. So what will happen? Initially, the fusion will decrease the rate of when a hydrogen amount of a hydrogen decrease, so the fusion will also decrease. As a result, what will happen? It will collapse. Collapse means, like example, the particles come closer to each other. When they will come closer to each other, the potential energy decrease, kinetic energy increase, so the temperature will rise. And when the temperature will rise, the helium fusion will start and the radiation pressure will be more than the gravitational force. So the size of the star will increase and it will become a red giant. And again, what will happen when the helium fusion will stop? Because eventually when it run out of a helium, the radiation pressure will be lower and the gravitational force will be stronger. As a result, the star will collapse again, but this time the temperature does not rise sufficient to start a fusion of a heavy element. Then eventually it will be a planetary nebula which cool down and turn into a white dwarf. So this one is question 3 from the same exercise 2 of space physics. So a teacher demonstrate the production of a circular waves in a ripple tank, and these are the wave fronts as you can see. Shown on diagram 1, the wavelength of a wave. So what is the wavelength? Wavelength is actually a distance between the two successive crest or trough or two successive wave fronts. So from one wave front to another, that distance is wavelength. Yeah, that's also wavelength, right? The next one, the teacher moves the source of the wave across the ripple tank. As you can see, this is the direction of the movement. The diagram 2 shows a wave at an instant in time. A wave at an instant in time. Diagram 2 is actual size. So, for example, if an upper object observer is there at X, another observer at Y. So as a result, what will happen? The wave, because it's the source is moving towards observer Y, so what he'll observe a shorter wavelength and a higher frequency. And observer X, what he will receive a longer wavelength and a shorter frequency or smaller frequency. So the question is, use the correct answer from the box to complete each sentence. In diagram 2, the observed wavelength at X has, if we observe the wavelength at X, it has increased, decreased, or stays same. So the observed wavelength has increased. That's right. And what about the frequency? The observed frequency has decreased. Yeah, that's correct. Then the next part, take measurement from diagram to determine the wavelength uh, receive it. So you have to use a ruler here. This you have to use a scale and just measure this length. Using your scale, you will measure this length and write it there. Frequency, no, in a Doppler effect, when the object moves from one medium to another, then frequency is constant. But in a Doppler effect, if the speed is constant, so that's why the frequency and the wavelength are inversely proportional. If the frequency increases, the wavelength decreases, and it will be other way around. The teacher uses a wave in a ripple that changes the wavelength from a different galaxy. When observed from the Earth, there's an increase of a wavelength from a light from distant galaxy. What we call this effect? When we observe that the wavelength increases, what we call this effect? No, is it Doppler shift is a change in wavelength, but specifically when it is related to the galaxies, as the galaxies are moving away from us, we call that they give us a redshift. Doppler effect is known as the effect due to the change in frequency and a wavelength due to relative motion, we call Doppler effect. But when galaxies are moving, we call redshift. But if galaxy is moving towards us, what we call that as a blue shift. Blue shift and red shifts are due to Doppler effect. Blue shift when frequency increase and the wavelength decrease. Red shift when the wavelength increase and the frequency we observe decreased. But the speed of the wave remain same in Doppler effect. What does this increase in the wavelength tell us about the movement of most of the galaxies? What this give an idea? It gives an idea that like, most of the galaxies are moving away from us. Then explain how this observation support Big Bang theory of formation of the universe. Like how a Doppler effect give an idea that there was a Big Bang which started. So what we observe the galaxies which are far from us. The furthest galaxy shows a bigger redshift. And it shows that the universe started from like it's of 4 marks, so 2 points related to the wavelength change, and points due to the cosmic microwave background radiation. So you will mention that the wavelength which we receive from the galaxies which are further from us, giving a longer wavelength. It means these galaxies are moving away from us. And the second thing, cosmic microwave background radiation, we receive them from all the direction. And these radiation, what we observe their frequency, their wavelength is also increased. So one is 2 mark, this like 4 marks are there. One is relating a Doppler or the redshift. Another one is relating the cosmic microwave background radiation. Is it clear? This one?
Yes, sir, clear.
So you will mention the points. The point you will mention, like the galaxies which are further from us, they're giving a redshift. Greater redshift means they're moving faster and they're moving away from us. So give an idea that the universe is expanding. And it all started with the same 1 point, and then to conserve the momentum, everything is moving away. Then state one piece of evidence that support a Big Bang theory for formation. So another thing here, answer cosmic microwave background radiation. That is the evidence of the expansion of formation of a universe or a Big Bang, supports the Big Bang. How it supports the Big Bang? It says like we are receiving cosmic background radiation evenly from all around. If the universe like it expand, and same thing, the wavelength which we receive from these radiation, it is increasing, getting longer, shows that the objects or the stellar objects are moving away.